Good morning, everyone. Welcome to today's Knowledge Hub session. We have a mentor of change with us today, Miss Sarbani, who will be walking us through her Knowledge Hub session on machine learning. She's prepared some brilliant. She's prepared a brilliant presentation on how you can essentially do a lot of the machine learning applications through minimal infrastructure and setup required at home. And yeah, I think with that, I'd like to hand it over to her for the session. Just on the session setup, we'll have the first 40 to 45 minutes of her walking us through the topic. And after that, we'll open it up for questions. You can put them in the chat and I'll ask them to her once we open it up for the Q&A. So thank you everyone for joining in, and over to you, ma'am.
Thank you, Haria. Thank you so much. Good morning, everyone. Thank you so much for joining today. It's morning, Sunday morning, and you all are here to talk about technology, and now that's fantastic. We are going through a lot of trouble. I hope everybody is safe and well and taking care of the families. And still, yeah, we have to run the show. Okay, so today's topic is what we are going to talk about, cloud-based machine learning. Okay, just a second. Can you see my screen? I'm sharing my PPT.
Yeah, we can see your screen. Yes, it's visible.
Okay, and I think you are able to see the content of the PPT, correct? Okay.
Yeah, we can.
Okay, great. So in the today's topic, what are you going to talk about? Cloud-based AI and machine learning. So it's a huge field. It's a huge ecosystem. Definitely will not be able to talk a lot about each topic, but I will try to talk about the concept. And then I'm trying to just relate all the components together so that we can have a overall perspective. How can we build the model and how can I deploy it in the cloud and how can I use it for an end product. To start with, I'll just give you the brief understanding of AI ML. I think a lot of you already know about it. Then I'll touch upon the what is cloud computing all about. Then cloud-based AI ML and deep learning infrastructure, what is being offered by various cloud provider. Then a quick comparison between AWS, GCP, and Azure Cloud. They are the three key market players right now. And a demo. So I want to start the demo quickly so that you can see how things are happening on the screen on the cloud side. Okay, let's move on. And the last point is the build, deploy, run model in AWS. That is a part of AWS machine learning model itself. Okay, so as we are talking about AI ML, you know that AI ML are disrupting almost all the sector, healthcare, education, financials, marketing, real estate, everywhere we are seeing the presence of AI ML, and everyone is trying to get the most out of it, how to get the benefit from AI ML and can implement that in our respective area. It may be the educational area, to analyze the how students are behaving on an online learning platform, or what is their assessment after going through an online quiz or exam. And during this pandemic, definitely this edtech startups are coming up so well. You have seen there are a lot of acquisitions happened in the market at a very high level. Now healthcare is the definitely, it's right now we are sitting on the burning healthcare situation, and there are a lot of startups are already working on a lot of healthcare product, and they are trying to help the doctors and pharma companies to research and to get the most out of it by using a lot of AI ML techniques. Then there are normal business as usual is still there, like financials, real estate, marketing, supply chain. Everywhere we are using AI. Now AI ML, when we are talking about AI ML, there are two distinct fields. One is the research oriented. AI was there in earlier age as well. So a lot of research institute and high-end academics and academicians used to use the AI as a research element, but it was not so popular among us. There was a reason behind it. Reason is that AI ML is driven by data. And when we are talking about AI ML, I'll just touch upon the difference as well. So there we are talking about data. When we are talking about data, we need to collect the data, we need to process the data, and then we need to feed the data to our machine learning system so that we can teach the machine, and machine can start predicting some unknown scenarios on the basis of the learning happened. This entire process needs a very high-end infrastructure, computing power, and a lot of data. Earlier, it was not possible because of the different kind of technology we just started in the computer world and all. But now, after there are a lot of tech giants are there in the market right now, Facebook, Amazon, Microsoft, Google, and just name them, and they are coming up a lot of high-end technological platform. And with all the technology advancement in last several years, we have seen a drastic improvement in the computing power, data, because of all the online system, and this becomes easy for the research scientist and engineer to extract the data, use that in the machine learning system using a lot of high-end computing power, CPU, GPU, TPUs. You must be seeing all these words in your day-to-day technological world, and we can process the data and we can get information out of it. So it's because of this technological advancement, this AI ML area is now here with us, and we can see the result everywhere. Okay, now what exactly this AI, ML, deep learning, data science? So we nowadays we are using all those words, that very closely coupled. When we say AI, ML, data science, quite easily we are using these words, but actually there are difference. So AI, artificial intelligence, is a huge field. It's a master world, I would say, and there are several academic research, high-end research are going on. So far, we have achieved the narrow AI. What we are saying, this is just a narrow AI. We have not yet hit the second level. It's a very niche skill. I mean, we are at the very bottom level of the human brain. The way the human brain works through artificial intelligence, we are trying to understand that, but we are at the very narrow level. And this AI needs a lot of technology and lot of techniques, statistic, data analysis, infrastructure building, algorithm, mathematical concept, computer knowledge, computer programming like Python, Spark, and there are a whole lot of technologies are there. And then we can reach to a state whether we can build an AI. So one of the technique is machine learning. When we are saying machine learning, the word itself is talking about learning. I'll go to the next slide. So in machine learning, we are teaching the machine or code through data. I'll show you one example. So here, what are we trying to do? We are using a bunch of algorithms. They are trained with the data, and then we build the model. Now, it's like a student. So as a student, in entire year, we learn from the respective teachers, your parents, your entire environment. So as a student, we learn every day, every second, every moment. We are learning from various aspects of our environment. There is a proper school curriculum through which we are studying and we are learning. This is called the learning process. So you can compare yourself as an algorithm. So we are ready to learn. We have all the materials to learn because we have brain, we have eyes, we have all the sense organs which can accept the signal from the outside world, and it can learn. It can learn. So whenever we learn from various information, after end of the curriculum, we can say we are ready now. With all the knowledge, we are ready now. Then what next? We need to go through a test process, correct? Everybody has to go through a test process. The test is called the validation in the machine learning world. Exactly the same thing happens with the machine. We train the machine with the lots of data. When we learn, we know the result, correct? When we learn, we know these are the questions, these are the topic, I'll read and I know the result. I know the result. When I do the sum, I do the practice, I have at end, I can see all the answers are given. So I do all the sum and I can see, I can check my answer. Once I check my answer, I can check my knowledge and I become confident that yes, now I can do sum, I can do maths. End of the year, when I sit for the exam, then I get a set of unknown questions. Why? Because teachers and outside world want to test our knowledge through a proper testing process. So everybody will go through the testing process. The unknown set of questions are there, will give you the answer. Answer will be validated. Answer will be verified by the respective teachers and then they will come back with a score. And then we see grade A plus, A, B, C. So any kind of scoring system you can pick up, grading system, scoring system, marks, MCQ test. But at end, everyone will be evaluated on the basis of the marks or grading system, that how well I am trained now. Am I supposed to go to the next level, or I should sit here and spend some more time? Okay. And it happens throughout our career. Even when you go to the real world, you work, you do research, you start your own company, you will be doing the same thing again and again and again. And that learning process is going through me as well. So every day I'm learning and I'm sharing my knowledge and people are giving me feedback. This is not something correct. Okay, I'm learning again. I'm again re-evaluating myself and again I'm trying to build something. So that way the entire process goes on. So this is a machine, this is a learning process, and the same thing happens with the machine. Here, who are the student? Your machine. When I'm saying machine, it's a bunch of code, algorithm. In terms of language, Python, if you go and learn machine learning, you'll see a lot of algorithms there, and a lot of you must be working on that. A lot of startups are already started working on it. They have developed a lot of product. So machine learning is a bunch of algorithm. We send the data, machine gets trained, and they create the output. And then we use the model to predict some unknown data. Now, what is deep learning? Deep learning is another very advanced learning process. The mechanism are different. Machine learning, the way the algorithm is trained, deep learning algorithm is trained in a different way. Here we try to create neuron. Neuron is there in our brain. And here we have several millions of neurons. It's kind of small code, you can say again. These neurons try to understand. Let's say I'm doing an image processing using deep learning, then each and every image, the specification of the input features will be understood by the deep learning neuron. There are several hidden layers between input and output layer. So it's a very high end study. So I don't want to go deep into this, but yeah, for now, just understand this is the machine learning, this is the deep learning. Deep learning is now currently we are using deep learning in image processing, text processing, where we need to process whole lot of high infrastructure data, and video streaming, recommendation system in Amazon, Netflix. We have seen a lot of recommendation system, correct? When we watch the movie, generally this platform start recommending the movies what I like to watch. How do they get that? Our the customer behavior, the way we behave on our online, we search, everything is captured. Nowadays we are totally captured by the technology. Totally, every single giant, they know what I'm doing today. Facebook, Amazon, everyone, what kind of shopping I do, what kind of dress I like, what kind of movie I watch, what kind of news feed I want to see, everything is known to the technology world. It's open. I mean, you can't just avoid it. Now, all these customer behaviors are captured in the system, and how do they use it? In marketing, pushing ad. The moment I'll open Amazon, you will see all the similar kind of ad on my Amazon page, what I bought probably yesterday or day before yesterday. If I open my Netflix, you will be seeing all kind of movies, what I generally watch, they will be coming on my screen. Same way, YouTube. If you are watching a lot of the technology videos or game, if you play, a lot of students are here, I can see. If you play a lot of games, if you open the YouTube, I can see what all games you are playing. That is another world. They are capturing all the student, and they are capturing the brain actually. And AI is using in the gaming world a lot. Now, what is data science? Data science is coming as a whole. So when a data scientist start work, he or she has to work on all the various aspects. Again, there are several aspects. I'm not going to go deep into that, but just understand there are several technologies, several infrastructure, several kind of tools and techniques are used in this entire world. These four circles are huge. A quick look, different kind of machine learning technique. At the broad level, there are two different machine learning. We are talking about supervised learning and unsupervised learning. In supervised learning, we are talking about tagged data. What does it mean? I can show you a picture. It's a Tom and Jerry picture. Everybody knows who is Tom and who is Jerry, correct? This is Tom and this is Jerry. How do you know? If you look at the feature and picture, more or less they're same, correct? Cartoon character. But by looking at the color, and there are several pictures, if you ask a very small child, he will be able to tell you who is Tom and who is Jerry. This kind of data is called the label data. When let's say I created one algorithm, the middle portion is the algorithm, and on the left hand side you can see all the Tom and Jerry pictures, but each picture, if you look at it, I have written the name. Tom is Tom, Jerry is Jerry. Tom is Tom, Jerry is Jerry. Now this data, when it is sent to the system, the algorithm will learn from this feature. This is Tom, this is Jerry. By looking at the image, by looking at this particular feature, it will store all the pattern. Who does that? Algorithm. You can see the brain-like structure. This is algorithm. Everything is done through the algorithm, and this algorithm can understand the pattern from the image and store the pattern and learn it. By running it again and again, they learn it. So once the algorithm will learn this pattern, after that it will become the model. Now use this model as a model who can understand image. You can say it is an image classifier model. Then tomorrow, if you show some different kind of Tom and Jerry picture, the model will be able to identify it. This is called supervised learning. And this is what we generally do in our day-to-day life. As a student, we all learn through the books, correct? Everybody tells this is history book. Then I know, oh, this is history, this is geography, this is physics, this is chemistry, this is math. And each chapter has a lot of information and tagged. I know what is what. Somebody has told me. This is called supervised learning. Under supervision of something. Then the other field is called unsupervised learning. In unsupervised learning, data is not tagged. We call them unlabeled data. Data is not tagged because we could not tag it. The data is so complicated, so complex, we could not tag it. So what we do, we just throw the data to the algorithm. So here algorithms are more advanced. So algorithm itself can understand what's coming inside me. Algorithm knows I have to look through all pictures if it is an image, and I have to understand what is this all about. I mean, algorithm itself will try to create the groups. An algorithm will tell us, oh, this kind of pictures are coming under group A, this kind of pictures are coming under group B, C, that way. An example is customer segmentation in marketing, where a company doesn't know about their entire customer base, but they have, like Amazon, they have millions of customers. So how to cluster the customer? So generally, there people use supervised learning. It can be customer by demographic, customer by state, customer segmentation by age, customer segmentation by gender, customer segmentation by shopping behavior, like a set of customer, young customer, mid-age customer, the female customer, group of male customer, and depending on that, they try to capture the behavior and push the product. Supervised learning mostly used in most of the cases. Example is that object detection. So you have seen there are several healthcare products are already launched where they can look at the image and can tell whether the person has is wearing mask or the person is not wearing mask, whether the doctors are wearing full PPE or not, and they score them. if the person is fully protected or not. So there are a whole lot of use case of the image processing. And then text processing. How do we use the text processing? Chatbot. So there are a lot of technologies are there in the market where we are creating the chatbot. That is called text processing. Where when I'm writing a sentence, the sentence is captured in the system, broken down. We call them, actually, you can say it's a kind of word, and then the word is analyzed and information is extracted. And then we build the chatbot, so the chatbot can talk to us to some extent. And it depends how intelligent chatbot you can build. So there are several use cases of machine learning in terms of text processing. Image processing is generally we are using the computer vision. So where in image processing, again, healthcare, you will see a whole lot of use case of image processing, like pulmonary disease infection detection. By looking at the image, the way doctor scan through the images, the machine can scan the image and can predict whether this particular image is having a particular I'm sorry, it's kind of annotation request. What is the, what do you want to annote here? Somebody has sent some annotation request, I'm not sure. So in this kind of image processing technique, when so machine is trying to automate some of the doctor's work, like the way doctor look through the images, the same way, if we can build a machine which can scan through the image and can predict whether this is a infectious disease or if this is something, let's say talking about COVID, pulmonary infections, whether it's a COVID or it's a non COVID patient. Then cancer. Then yesterday only I saw one news where Google Health is launching one app which will be able to take the picture of our skin and it can predict whether the skin has a typical skin disease or not. So these are all prediction. Also preventive healthcare. By looking at the different medical parameters, doctors are coming up with a preventive healthcare system. Even before I am having the disease, doctor can tell me, yes, at this age you may have this disease, so here is your preventive medication so that you can prevent the disease in the later stage. So there are a lot of research and a lot of advancement are happening with this kind of machine learning technique. Now, when we're talking about this kind of machine learning technique, we have to understand how are we going to build, how are you going to start it. Just a second, my screen is a bit frozen. Okay. So let's not look at all the stuff here. They are quite depth machine learning knowledge. So two things you can remember: supervised learning, unsupervised learning. In supervised learning, we generally solve two kinds of problems. One is classification problem, one is regression problem. What is classification problem? Where we are trying to figure out what is the class of the object. Again, an example, let's say I'm taking an image, object detection. Let's say I'm doing an object detection. I have taken a few object picture. I want to classify whether it is animal, whether it is a non-living thing, whether it is a human picture. Okay. With this classification, then I'll be using a supervised learning technique, which will be able to classify the image into 3 different classes. This is a classification technique. Regression technique, let's take an example of marks of a student. A student can have, literally can have 1 to 100, anything in between as marks. So this is a number. It's a continuous number. If I have to 2021, I want to predict what will be the marks of a student in 12th board. If there are 10,000 students are coming under my analysis, I have 10,000 students and there will be 10,000 final marks in terms of percentage, which can be anything. Correct? Which can be anything. It can be literally, it can be 1% to 100%. So this is a continuous marking technique. Then this is called regression. I can group them. That's a different analysis altogether. But right now, if I just look at the number, it can be any number. Then this is called a regression technique. Another example, housing price. If I want to predict the housing price for a particular, let's say, For that, first I will gather the last 1 year of data from the similar area, Delhi NCR, for different kind of housing property with different features. How are you going to predict the housing price? Normally, number of bedrooms, number of bathrooms, number of balconies, whether there is a nearby market or not, schools are there or not. In Delhi NCR, we look for the metros are there or not, market area, and blah blah blah, malls are there or not, and doctors, hospitals are there or not. There are several characteristic features are there for a particular case. So on the basis of that, we try to predict what is the output of the particular housing estate or price or society. So this is called regression technique because the pricing is a continuous number. Okay. Now in unsupervised way, we generally talked about one clustering technique. Rest you can, for now you can skip this. This is not, okay, leave it. There's a lot of information. So let's move on to the next thing. Classification, regression, clustering. These are the three major categories of problem we are trying to solve with the machine learning problem. Okay, and you can do a lot of interesting project here. Sensor data. If you are interested in Arduino and sensor, you can gather all the sensor data and you can predict what is the weather of a particular day or what will be the climate of a particular area. And a lot of sensor data analysis are done with the machine learning technique. Okay, it's all about AML and how can do this, how the use case. Now what next? How to start a ML problem? So there are various tips of machine learning problem. First is the data collection and data gathering and loading the data in your system. Where exactly you want to create a code, where exactly you want to load your data, and where exactly you want to analyze your data. This is very important. Then comes the model part. Model development, model training. Model means machine learning model. Model development, model training, model optimizations, model selection, model evaluation, model implementation, inference, decision, and visualization dashboard. This is a kind of overview of different steps what we generally follow in a normal machine learning project. Now, when I'm saying machine learning project, it can be your own project, research project. You may be working on a startup prototyping idea for a pitch deck, what you will present to the investor. If it is granted, you will come up with a product and then you want to package it and sell it. It can be your own research area, like you are studying in this area and you want to come up with lot of research ideas and you want to do the prototyping and you want to submit some result. Why people do a lot of research in this area? This area is full of open technologies. One of the most important technology or coding language is Python. That's what we use in the machine learning area. Python is the open source technology. It's a huge community. People are learning on their own. Students are learning on their own, and they are building fantastic project because they have a lot of good ideas. Now technology is completely open. There are a lot of people are suggesting how to do the stuff. There are a lot of materials are available in the market, and they are building very nice product. But that is at the prototyping stage. When I'm saying data collection, data loading, so let's take an example, image processing, again object detection. So what you will do, it's easy to collect the data image, correct? If you have a camera, you can just go around your area and you can collect a lot of images. One example, you want to detect a project which can detect what is the good leaf and what is the bad leaf. Means there are a lot of leaves which are defective and then farmers want to remove them. A lot of robotics machines are using drone and camera. They take the picture of the huge land and this kind of picture are sent to the machine learning system. Machine can detect this area is defective, this area is not defective, this area is bad, and then they can control the drone, send the drone or robot, and they can pluck all those bad leaves so that it does not spread. And if we do it manually, it takes a lot of time, and by that time I'll reach to the other side of my land, most of the land will already be infected, which is happening in our medical situation as well. So you can see, correct, logistic is a problem. Knowing the problem is one thing, coming with different idea is one thing. In last few months, I have seen so many apps, so many links which are giving us leads of oxygen, leads of hospitals, information, but they just run for a day or two, and after that they all are gone. Why? Because there is no data. You have a technology, you have a product, you have a dashboard, you have an app, but if there is no data, nobody is going to use that. There is no centralized location where I can go and find out, just entering my PIN number, vaccination information, what is the hospital status, what is the oxygen status of my area. People are building, but they are going out of the resource because it has to be maintained properly. If you want to build something, you have all the nice ideas are there, but problem is that when we build the product and we launch it, after certain point of time we don't maintain it. Maintenance means when you are running something in a real production with all the resources it will need. A system doesn't run on its own, and fantastic high-end application doesn't run on its own. It needs information, it needs data, it needs a bunch of people who will be running it continuously. If the site goes down, who is going to put it up? And it happens several times in last few months. A lot of new applications are coming up to solve some of the problem, but most of the time either they are down because they are launched quickly without any infrastructure help, proper performance. So people are hitting the site goes down. So you need a constant maintenance of such kind of product or system so that people can use it in the long run. Otherwise, people will not use it. A fantastic idea will be sitting idle in a shelf, and that's happening in most of the cases because products are there, but we don't have a proper infrastructure to run the product, so we are not able to get the benefit out of it. Here exactly comes the cloud computing. And I know there are a lot of students are listening to me. A precaution, please. This cloud computing is a paid service, correct? They do give a lot of free services, but when somebody goes to AWS or GCP or Azure cloud, you need a credit card to create your account. So if you are under 18, you can't do this on your own. You need your parents' intervention or mentor's intervention or school teacher intervention. They have to understand your requirement. Why do you want to do this? As a student, if you want to run something, because students, I don't expect they are going to make any product at this moment which is going in production. For learning you can do, but under your teacher's supervision, because it may deduct some cost if you don't know how to use it. So please remember this. And if you want to run something on your own day to day, anything, any kind of project, any Python code, any kind of model, run on your system. That's enough for your student level work. But this is, I'm going to touch for the people who have fantastic idea. They want to start some startup or product, and they want to use the cloud as the starting journey, so that customer can come here, take the trial version, and they can go for a subscription model, and it can be monetized in terms of revenue and further use. It's kind of, I would say it's an industry and enterprise level solution. When I'm talking production, it's an industry and stuff, but for the normal day-to-day school project, you probably don't need. But yes, if you are interested, you can learn, but please do it with your teacher or technical mentor or parents, whoever can help you. What is cloud? Example, I always give a society apartment versus independent house. When I'm living in an independent house, I have all the benefit. I have a nice terrace, I have nice garden, but I have to maintain my garden. If I have a lot of money, probably I can have a swimming pool for myself. I have a guard who is guarding my entire premises. I have lovely pets. If I love to have pet, I have all my beautiful gardening and everything. But that is on my private premises. So whatever infrastructure I have to maintain on my own. I have to pay the cost for that, for each and every facility what I'm building in my premises. This is called normal enterprise and on-premise. If you see the first block, on-premises, this is exactly this independent house, kind of an independent infrastructure. any company is building on its own. If you have in your school, if you have a 3-4 servers, you have created a normal IT room, that is your on-premise data center. But now compare, I'm moving from independent house to a society where I have 2000 people are living in a high-rise society. There also I'm getting all the benefit, lift, beautiful garden, joggers park, lovely clubhouse, food court, blah, blah, blah. There are a lot of societies are coming up with a lot of big things and good things. With all these things, when I'm having them, I'm getting all the benefit, but infrastructure cost is now divided among all the residents. Everybody is paying the maintenance fees, so I am giving a part of that. Now if I don't use, most of the time we spend time in the office in the daytime, we don't use the clubhouse and all the luxury products. When we come back in the evening, I'm using that. But when I am not using, somebody else is using all the facilities. The people who are living in the society and who staying in the morning, they goes in the morning slot. The people who are going to the evening slot, they got the evening slot. So it's a shared architecture. So it's a shared infrastructure. So cost per family will drastically go down. So I am getting the similar kind of facility with a less cost. Definitely I'll go for that until unless I have I have a lot of money. So second thing is that platform. So here also cloud gives the similar kind of benefit to the customer. So they give, instead of you maintain 4 servers to maintain the school data in one server room, you go to a cloud service provider. They will give you 3-4 machines where you can keep your data. What is the benefit? Everything is virtually placed online on internet. You don't have to go to the school to switch on off your server or do the maintenance. Who is going to do all the maintenance? Your cloud provider will do all the maintenance. Who are my cloud providers? You can have a quick look. Nowadays we have AWS, Azure and Google Cloud, GCP. They are the 3 major players in the market who are providing end-to-end cloud services to every single person. And good thing about them, they will treat me as a client. They will also treat TCS. They will treat Accenture as a similar kind of client. Yes, the customer support level will be different, but anybody can go and create an account with this cloud provider. They don't check who am I. They don't check who am I. I am equally important for them. For this demo, I raised a ticket 2 days back with Amazon, and their SLA was 48 hours. I put that I have a demo, I have to use that. And yesterday night, I got it closed. So, and yesterday night and set it up. So I am getting an equal amount of services from this cloud provider. The same way they provide the service to a big tech giant. So that's the good thing about it. And let's move on. I'm going to show. So there are some difference. I don't think you have to look for this. Just a second. So today I'm going to show you one demo on AWS SageMaker where I can run a machine learning model quickly. Okay. So I'm going to my AWS screen. I'm going to show you how does it look like. So this is AWS console. So everybody, if you just go there and type AWS console, and I have created my own account. It takes credit card, as I said, and I created account. 1 year free subscription are there. So mostly all the clouds, they give the free subscription. What does it mean? So there are a lot of services. If you go to the cloud screen, there will be a lot of services are available. At a high level, cloud gives the computing power, means you can compare it as your laptop. If I have one laptop and it doesn't have too much space or processing power, I can go to cloud and I can buy one machine there, high-end machine. Now within the 1 year free subscription, I get moderately good machine. And pricing is very important. Generally, we need to go through the pricing structure. But within 1 year, mostly I can run a lot of demo, lot of research and lot of POCs without providing any cost. Not only that, they do provide free credits to the startup. So if you they do conduct a lot of webinars and seminar, we can join there. And if they see you are doing a lot of work on a particular account, they give you a lot of offer that you will get free credit and all. So like I collected a couple of free credits for that, and they are really fantastic. So once you have this AWS console, generally you have to sign in here, sign into the console. So I have already signed in. This sign in information is again very important. It's a very personal information. You should not share it with anyone else, because anybody can go and mess up with your account, and then end of the day you have to pay for it because your credit card is already there. They will deduct the money. So just be careful with all this aspect. I'm not expecting student, but yes, even if you are using the cloud for the first time, make sure once you are working on the cloud, before going to the sleep, the way you close all the doors, you have to close all the cloud instances. Otherwise, overnight cost will go. Now this is the cloud console, correct? And I right now I'm on the machine learning solution. So cloud gives a lot of solutions here. You can see product. So EC2 is a computer. It will give you an instance computer. Like I can buy a Windows machine, I can buy Linux machine or Ubuntu machine, anything. Then RDS is a database. I can buy one RDS, small database, Oracle database as well. VPC is something related to the network. If you want to secure your cloud, when you want to make a production ready product, you have to secure it. And especially in the machine learning world, definitely, because you are using a lot of customer data. So like student, you are using student name, student demographic, student age. They are very sensitive data. Then I'm using here Amazon SageMaker. So what does it do? Build, train, deploy machine learning models at scale. Why at scale? I can run anything on this SageMaker model with very high-end machine. Image processing, text processing, they need a lot of high-end infrastructure at the GPU level to process the image. Image processing takes a lot of infrastructure. So if I run, like look at it, I'm showing you. I also have my own Jupyter Notebook. This is my local environment. This is my local environment. So if you look at it, so here you can see this is my Jupyter Notebook. This is my code is running. Even I can go there and I can launch my Python quickly. This is called Jupyter Notebook. If you are working on Python, you must be knowing about it. We generally use Jupyter Notebook to write any machine learning code. And I can write anything here. It's my normal local Python script. And I have a whole lot of projects are running here on my local. But when these are just example. This is local. But the moment I'm going here, this is not local anymore. This is in AWS. Okay, in AWS, this is my Amazon SageMaker console. You can see in Amazon SageMaker console, you will see the notebook. So the same notebook, what I showed you on my local system, that is here, notebook instance. If I click on the notebook instance, you can see this is the demo notebook instance I created. Look at the machine size. This is ML M4X large. It's a very high-end machine. Why? Because I wanted to show you the image processing demo. So this demo, now this is the code. This is a typical machine learning code. Let's take a look at it. Don't worry about what is written inside the code. This is a very advanced code. So here what I'm doing, it's a multi-class image classification example. What does it do? Here the model will be trained on various objects, and after that we'll test the model at the end point with some unknown image. So here is this is a Jupyter Notebook. You know, in Jupyter Notebook, you can write fantastic word, note, text, you can format, and you just shift enter. It will, now I'm running the code. Look at this. Now I'm running the code here, but I'll not destroy my demo because it generally takes 10 to 15 minutes to run. So how to open it? Here, look at this. This is the instance is running. It's kind of one machine is running here. You can instance means we can see one machine is running here. On this machine, I am opening my Jupyter Notebook. Just right click. It's opening just click. But you have to understand what I'm clicking. You have to be careful. So I'm opening the Jupyter Notebook. Look, the notebook has been opened. I have written, there are 3 codes are here. Okay. One is random cut forest. So this is a machine learning code which is going to predict that anomaly in a taxi ride data. Like every day, let me open it. So every day, how many people are riding in a particular taxi service like Ola and Uber? And you must have seen the trend on all the shared taxi services, correct? What you have seen, that this is simple data. You can see timestamp and values. So you can see in this timestamp, this many people have traveled through the taxi. So it's a data taken from this particular link, and this data is processed here using this model. And how it is being processed, this is already, I ran this on AWS because it takes 10-15 minutes. I'll run it in front of you. If it is done, it goes on well. I'll just show you the output. So every time, how to run this, just select the code is now open in the AWS. I just go and shift enter. You have to run the code, by the way. You have to write the code. Now once code is ready, so this is called model development. So I'm building the model here. So the word build, so I'm building the model here. Here I have imported all the Python libraries. Here is my data set, CSV. I loaded it here. This is the data loading part. Remember I was showing it, the data loading part. Now it comes here, obtain the inspect example data. Now here I'm looking at few of the data. I have to run everything one by one. So I'm just running the code, okay? Run. You can see training input output will be stored here in S3 SageMaker particular region. What does it do? In AWS, the data is stored in S3 storage. In our local system, we store our data in our Windows folder. And in Jupyter Notebook, when we open the data reads from the local drive and then it processes and model is developed. But in cloud, data is stored in S3 storage. Where is the S3? Here it is. So this is the S3 bucket. I can show you. These are the services I'm using. For today's demo, I'm using S3. I'm using S3 Amazon AWS SageMaker. Yes, I think I mostly use this too. So I'm opening the S3. I'll show you where exactly I'm storing my data. Okay, so you can see I have created several S3 bucket where my data is stored. And here exactly my data is stored for this particular demo image class. So you can compare it as a database, but not formatted data. It's kind of, you can put anything, image, text data, number data, structured data, CSV file, JSON file, HTML file, anything. You can dump anything here in S3 storage. It's very powerful storage, because in machine learning world we use structured as well as unstructured data, both. So if I have a database, if you know about database, Oracle or SQL database, that will work for the structured data. Like I can create one Oracle instance and I can work on this. That's true. But here, I don't know, correct? I can have a text data, I can have image data. So for that, S3 is very powerful storage where I can store all the data. I can just dump everything. It's kind of a data lake. I mean, it's not data lake. Data lake has a separate solution. But yeah, S3 is kind of giving us that power to store anything. And I'm opening this now here. This is my data, correct? Here I have stored. You can see demo image classification, and there are two folder, train and validation. In the train folder, I have stored all my training images. I'll not be able to open it here in AWS because it's a few MBs of data. 20,000 images are there. And so that kind of scale you can use in cloud. I did one research with 20,000 images on my local laptop. It took 6 hours. I ran it in the night and I got the result in the morning. And here yesterday I ran it in 15 minutes. So that's kind of infrastructure cloud is providing. So for demo purpose, generally, if you are having a product, you want to go for an investor pitch, definitely you have to use this kind of cloud infrastructure for a couple of hours. Otherwise, you will not be able to show them the result. Nobody is going to sit there for 5-6 hours. And now here is the validation set. So training data is used to train the model, and the validation set is used to test the model. And how it is tested. Now again, I'm going back to my code. Look at it. So this is what my code is saying. Training data. This is the path I'm highlighted here. The same path I showed you on the console. That's the nice thing about it. You can code on your Jupyter Notebook and you can check that what is happening on your console itself. And so now if this is done, then you can go to this obtain inspect data, and here you can run the code again. Look, the data I'm running it, correct? It is also giving you how much CPU time. See here, data download, how much time it took to download the data. It will tell 29 milliseconds. Then here I'm loading my data. So taxi data dot head. I'm loading the data. It has only timestamp and total number of people are riding. What I'm trying to understand, this is a day pattern. If you look at normal Ola, Uber, you can even clearly see that. Early morning rush, kind of student rush, morning 6 to 8. After that, people start going to the office. The people who go to the office on a normal working hours, because nowadays that is another trend. So if you look at the this kind of graph in an area where you have a lot of banks and government sector, government offices, you will see the high peak are coming up between 8 to 11, because by 10 to 11 all the government officials are there inside the office. But if you take this similar graph in a IT sector, you will have a very different. IT sector sleeps in the morning. So generally we go to office around 12, because mostly people work with the global customer, and also generally we start our day late, we go late. So 12 to 9, 12 to 2 o'clock at night, you will see this kind of peak in a IT sector. If you look at the taxi ride pattern of a mall or hangout area, there you can see the evening pattern will take the peak. Now, why do you need this? Depending on this pattern, the Ola, Uber, they generally arrange the cab on those areas, correct? If you send 100 cabs in an area where you do not have any ride request, it's totally wastage of money. How do they optimize the route? So this Ola, Uber, they are using this AI and machine learning platform so effectively. They are coming up with so efficient and optimized route. Correct. So where exactly is my crowd? I have to understand, and then I'll send my cab to that area. If I don't understand this picture, I'll not be able to manage an optimized route, and I'll not be able to serve the purpose of the public. So people will not use my cab. So they are to look for a Uber or Ola cab, and if cabs are not there in that particular area, so they will switch to different vendor, correct? So this kind of pattern analysis are always done on with this tech companies and with this business, and they spend a lot of money on the infrastructure, on the technology side. Now, if you look at this data, anybody can say there is a spike at 6,000, correct? At the 6,000 record, there is a single line spike. So this is a kind of outlier or kind of anomaly. What happened here? So the people from the business will take this data and will try to figure out what happened here. Correct? So this is a kind of analysis you can quickly do by running this kind of code in cloud, and you can quickly run it. If you want to run it in your local system, you can run it, but it may take time if you are using a very high-end data. Now I don't have much time. I'm quickly show you the image one. So this is a kind of analysis done with this anomaly data, and here is the image one. So in image one was created with this is a CNN model, convolutional neural network, deep learning model used to train the algorithm with lots of images, and here exactly the inference. So once the model is created, then we tried to test it with another image. So it was tested with several images. And finally, I tested with one image where it was given bathtub. But now see the real life problem. You trained it. Now the inference side, when we are trying to see the result quickly, cloud processed everything and it gave me the result in terms of probability. The picture I'm showing, the bathtub, the probability the picture is a clutter 7%, Mars, mattresses, spoon, bathtub, few. I just entered few object name, but you can see the result is not so correct. That's actually real life problem. Most of the time when you run a code will run syntactically correct, but the problem is the result and accuracy. Here the accuracy has quite dropped. You can see I was expecting it will be able to detect the image as bathtub as a good prediction. What it is saying, what is the prediction probability of this picture, that it is a bathtub. The probability is coming up as 2%, but I was expecting at least 70%. I mean, no, sorry, 7%, at least that is at the higher side. But at the first prediction, it is saying probability clutter. Now, why so? Because I used very less number of images. Not only that, the training needs lot of iterations. I did not do that because I just spent 15 minutes yesterday to train the model. If I do it for, now here comes the machine learning, core machine learning knowledge. So here as an engineer, as a machine learning engineer or professional or data scientist, people want to spend time here in this analysis, optimizing the model, increase the accuracy. But I don't want to spend time on this entire infrastructure building. Who is giving me the infrastructure? Cloud. If I want to do it in my system, I would have spent 2-3 hours to build this environment because I have to go to the collab. So yes, there is a very fantastic environment. Google Colab is given that you can use. So Google Colab is another uh, cloud. It is coming with your Gmail. Just go to Google how to do this. I'm quickly show it, and all the students can go and use the Colab. That is another fantastic machine learning environment. What can be used for most of this deep learning and high-end machine learning model training. When I'm opening it, I think I can stop now. And I think there are some question, answer, and doubt. So this is the collab. It's a link to your Gmail. Every single person has a collab, and we are so lucky. And 15 GB is free. But remember, Google cleans all the running code after I think 8 hours or 10 hours. So if you are running something which is more than 8 hours, you will not be able to see it in the next day. So, but yeah, 4, 5, 6 hours you can run it. Any code, and it's a complete machine learning end-to-end environment. You can just go and run any code, TensorFlow, Keras, and it's a fantastic. And we generally run fast. We generally run here, and then we look for the cloud. And here you can see the code. You can start coding directly. You can go and you can open your notebook and you can start coding. And it's another cloud. It's on GCP. It's on Google side, but it's coming free with the Gmail account. So this AWS SageMaker, the similar kind of environment, you will get it here as well in the Collab side. That is another good way of doing. But yeah, in Collab, the problem is that endpoint interaction is not there. What is here? Like once you build the model, how to use the model output for your own application. That is not here in Collab, but that you have to build. But that can be done very easily using the SageMaker. So in SageMaker, the model I have built, that is already available on one endpoint, which generally comes here. So I'm showing it. So here model is deployed, developed, deployed, and output is available to some at some place, because now you want to use the output and sell it to your customer, correct? So here it is available. So notebook is created here, processing is done here, training is done here. Now here is the endpoint. So I'm showing the endpoint configuration because I had to delete the final endpoint because it is very costly. So I did not open it overnight and I don't have time to run it again, but I can show you the picture. So this is the yesterday I created. You can see May 22. So this for demo, this endpoint configuration was created and anybody can come here. This is the API client. So if you are sitting in your school and you want to use that object detection output in an application which is running in your school server or any other web server, you can call it as through API, or there are several techniques. It's kind of client server technology. You can call it and you can use it in your application. So this endpoint, this is I deleted, removed it yesterday. So I can show you the picture of that. I took the screenshot. So when I was running it yesterday. So here you can see the image picture. So this is the endpoint. It's saying the image classification, what I built on the SageMaker notebook is now available here. You can see the status is in service. That means it's running as another service. In cloud, everything is as a service. You can go and you can buy it. So if you want to build a product, your product is ready. You can use anything, AI, ML, text processing. Your product is creating the output and output is now will be available here at the endpoint. And what you will say to your customer, please come and get the service from here. Now here you have to build some technology, some mechanism to push the service to the customer side, and there exactly you start getting your benefit. Okay, I think I have to stop now, and so if you have any questions, probably we can open for that.
Yeah, absolutely. Thank you, ma'am, so much for the session. I think it was really insightful. I think we can wait for another minute or two to see if we have any questions, because I think your presentation was quite elaborate and covered most of the things. Plus, we're almost at time.
Yeah.
There's one question: what option we should use for website hosting in AWS?
So website hosting, so you can use the EC2. There are several options are available here. So EC2, then for there is another one, compute one, Elastic Benstock, that is another option you can use, or you can just get any EC2 instance as in Windows or Linux and you can host your website. But yes, I mean, you have to be careful about the costing and all. I mean, it depends what kind of website you want to host. If it is a production ready, how many people are going to use that? What will be the load? So if you are you want to launch your own website, like I have my own website for my center, NextGenBot, but that is running on GoDaddy, because AWS is kind of, I would say it's very enterprise version. If you want to run a website on AWS for your own setup, it might be a bit costly. But yes, if you want to build a very enterprise level website, then you can go here. Otherwise, even there are other Bluehost or GoDaddy. They are also giving some good offering for the Indian customers. But here in AWS, you will see very high end and I mean, if your website is going to be built and you want to build something where a lot of people are hitting the website, then you can think about AWS. You have to do a cost comparison for that. I mean,
Yeah, there's
otherwise you can go for.
Yeah, there's another question on is Python or MATLAB better?
MATLAB. Okay, so MATLAB is kind of I would say I like to do work in Python because Python has a huge community. Then Python comes up with lot of inbuilt package which can be integrated with this kind of cloud or any downstream system, or even Python has got a very fantastic Django framework Flask where you can build your fantastic website and user interface. Because it's not only that you build the model, correct? You have to think about how are you going to send the output of the model to your customer. So there exactly you will be taking help from the front end developer. Either you have to hire someone from .NET or Java developer who can build the UI for you, or you can use Python end to end, because Python has very good features of lot of UI, and a lot of fantastic websites are now built with the Python. So I would say Python. If you want to work in this area, then I think Python is right now. Python is there. Everything is there. You can integrate with anything easily. Yeah, please, next one.
Um, I think we can take this one last one, which is there any website for ML examples?
Oh, there are a lot. There are a lot. So, I mean, you have to be probably a bit specific. I mean, if you want to learn, there are so many things are available in the information are available in the market. So it's better you go through a mentor or someone who knows in this field. Otherwise, you will be overwhelmed depending on your level. If it is coming from student, then student definitely you should talk to your ATL mentor and go through a proper structured way. And if it is coming from professionals, yes, self-learning is good thing. And you can spend a year if you are early at your early career, you can you can spend 1 year and you can go through your side. There are a lot of courses are available like in Coursera and Udemy, but you have to check what is authentic. You have to be in touch with someone who knows this field, because there are a lot of information. So yeah, if you have time, you can spend, and after 3 months you will be able to know, okay, which is correct, which is not correct. There is a different comparison, AWS, Azure, and GCP. So, breadth, if you talk about the number of services, AWS is still there. I mean, it's a huge number of services, and Azure product is still there for the Microsoft product. So if you have a Microsoft product, then it's best to go for the Azure. But if you are working on a various technologies, then I think you can also try with the AWS. And GCP is really good in terms of machine learning, TensorFlow, Keras. They are coming up with fantastic machine learning platform. But yes, Azure has marketing is different. It's a bit costly. Azure side, you may land up at a higher cost if you don't have a good, good offering from Microsoft. Microsoft they're giving a lot of good offering to the big customers, but yeah, you have to negotiate a little bit. That yeah is good. So in machine learning area, these three giant players are really fighting, and good thing is that we are getting the benefit because they are coming up with free things, free tires, free credit. So it's good for POC research. It's really good.
Yeah, thank you so much, ma'am. I think those are all the questions we had for today. I think we can conclude the session now. Thank you, everyone else, for joining in. And yeah, hope you have a good Sunday. Thank you.
Thank you all. Thank you so much. Have a great day. Stay safe.